Okay, again, we will start with an outline or demonstration of the GUI, the graphical user interface of the VRE, which is then followed by the functionality provided by the command line interface. And then we will go over a short video that shows how the Jupyter Lab workbench tool can be used in the VRE, which is then followed by a demonstration of the high-performance computing and virtual machines for processing. So now I will share my screen and we can have a look at the GUI basically. So if we enter vre.charité.de, we are greeted by the landing page here and get provided with some information and links to the user guide. To access this page, it is necessary to be connected with the Charité VPN. If this is not the case, then this blue button up here would be gray, but it's blue, which means I can log in now and am greeted by the project overview page. So we have two main views in the VRE. The one is the project view and the other one is the dataset view, which I will show. So in the projects view, we get first a list of all projects we are a member of, which is 4 in this case, and I go into our test project, which is open for all VRE users and can be used to test drive the functionality. The project view then is separated into several sub-views here we can uh, that we can select here in the left sidebar. So the first view we have here is the canvas. The canvas is an overview. It's a file explorer. So it gives us high-level statistics of the project. It gives us the recent file stream. So what was uploaded or downloaded from this project. And it also allows to search this file stream. So the recent activities that have happened to get an overview which data was brought in or out of the VRE. Beneath, we have the File Explorer. And the File Explorer, the storage space for files in the VRE is divided into two zones. We have the green room zone and the core zone. So the green room zone is for onboarding data, for bringing data into the VRE, while the core zone, so really copying data into the core zone and exposing it to the entire project team, requires the status of a project administrator. So you have to have a certain role inside this project in order to be able to expose data to others. So if you now upload data, no one can see it, only you can see it. And in order to expose it to others, a locked operation needs to be performed, the so-called copy to core operation. So let's try this out. We are now in the green room and want to upload files. Here is the upload button. I created before a folder with some test data, actually in the meeting before. And here we have it. It's called demo data, and it contains a subfolder with a few test files. So now I click the upload button to start the upload process. And we get this message that it was uploaded successfully. We see here in the green room, we have a new folder called demo data, and it contains exactly the data that I just created in the previous meeting. And so we have here also nested folders with subfolders and with files inside. So now, as mentioned, this data lives in the, this was one too far. Let's see what I can come back. Actually, I'm a bit too lazy to look for my to look for my folder, so I will just log in again. Here it is again. So here we are again in the green room, and I now wish to copy this data I just uploaded into the core zone, making it visible for everyone in the project. So I select the folder, and here it is. Here's the copy to core button. I click the copy to core button and I click it again. And then I'm required here to enter a code to approve basically that I'm now doing a critical operation. And I'm selecting the target folder. We have many users here, but I'm going down until I find my home folder. That's what I wanted to avoid earlier, but now I have to do it. And select it here and confirm. So now I triggered the copy to core operation, and it will or is currently underway. So let's see maybe whether we get feedback here. Was it? It's in progress. It's waiting. So we'll give it a bit more time maybe. Still waiting. Something here already. Actually, something was copied already. Okay, now it's not in progress anymore. The operation is complete now. And we can see also the folder is here with all the nested folders. Right, so this is the one of the most important functionalities of a data management platform, the ability to upload data and of course also to download data. So I can just select the folder here and click download, and then the download starts. So, yeah, it zipped the file and downloaded it to my local hard drive. And yeah, so upload and download, this is the functionality and file explorer that we have mostly in this view. We have also a few other functionalities. For example, we can see the properties of a folder. So we can see some statistics about it. It's global identifier, so every file and folder has a unique identifier, and this can be used to create a lineage of files and processing steps, basically, of the evolution of files. I can also assign tags here, and we can also add
Micha, there's a question in the chat. I just read it for you. What are the requirements on the data before upload by Jill?
So the upload function is able to upload any file or folder, but of course there are some limits with size. So if we would now select like a terabyte size file, it would probably not work. So then we need to split it into smaller files and upload them as chunks and set them together again.
My suspicion is that the question goes a little bit in the annotated direction. So what metadata are needed, and maybe you can later comment on the possibility to also upload metadata, which is not a requirement.
Okay. Yeah, thanks for this clarification, Petra. Yes, so there any arbitrary file can be uploaded. So there's no special requirement.
But there's a functionality to also store metadata. And maybe, are you touching this later on? Is that part of your presentation?
Yes.
Okay.
Yes, this is part of the dataset feature. And also, I'm about to come to this point actually right now. Just let me briefly show the ability to create collections. So this is a more lightweight way to annotate. No, not really to annotate, to group files. So we have this very let's call it a structured way of creating data sets. So this is the dataset feature, and there we really can annotate files with metadata files. and also run then a bits validator. I will come to this later, but before that, let me just quickly show here this um, uh, collection feature. So here we can, this is a more lightweight way. So if we really just want to create a certain virtual folder, so to say, where we have certain files in it that we want to quickly find, but we can relatively quickly do this by just selecting the files and adding them to a certain collection. So this is the lightweight way. But as mentioned by Petra and brought up by Jill, we also wish for a very structured way of annotating data with metadata such that it can be better understood. And for that, we have the datasets feature in the VRE, and we have the attributes feature in VRE. And both together can be used for this purpose. So let me go step by step towards them. Before we go to them, let me just quickly show you the rest of these functionalities that we can access from the left sidebar. So here we have the search functionality. We can search for files. So for example, the file that I just uploaded, and we can concatenate this to form more complex queries. For example, with upload time, file size, and so on. We can also create announcements. Usually this works. Now it works. Yeah, communicate something to the entire team of users, of project members, which we can see here. Let's go quickly again away from this because it shows names of people. And here we can set settings like the file attributes, for example. So this is this now relates to the metadata annotation that we brought up earlier, and I will show this in more detail. But just to give you the full links that we have here, we have also here the workbench, which shows which of these workbench tools are deployed. So here we have the workbench tools, and this is on the one hand Superset, Guacamole, and Jupyter Hub, and XWiki. So Superset is a business intelligence tool that allows to work with large data sets, basically to visualize it and so on. Jupyter Hub is widely used for Python programming and creating interactive notebooks, which we will demonstrate with Mark's video in a few minutes. And Guacamole is our remote desktop gateway where every project, the virtual machine of every project can be accessed. So every project has a dedicated virtual machine, or also more if needed, that are the actual place where the processing happens. And this is what will be shown by Patrick, and also which can be used to then further transfer the data to the backend HPC. And finally here, the last button that we didn't mention yet is this requests button, where we have copy to core requests in case you have a lower role here. Then, as mentioned, you cannot directly expose the data to others, but you need to request this from the data controller who has the legal role for doing this. Okay, and now let's go actually to these file attributes that I promised you for so long now, and the data sets. So the file attributes are metadata. You can here customize metadata. So you can create all kinds of field attribute templates with all kinds of fields inside. So for example, here we created a neuroscience template, which can also be exported as a JSON file. And then we can give it attributes. So for example, the data could be of a certain modality. It could be imaging, electrophysiology, and so on. It could be acquired at a certain site. Then we can provide a subject ID, and in this manner we can easily add more attributes as needed, basically, either of the form multiple choice or text. And we can create as many of these templates, basically, as needed, as desired. Here we can create new ones. We can also import existing ones, as mentioned, if we exported them previously. And how do we use these templates then? We use them in together with data sets, basically. So a data set co-locates data and attributes, basically. So data, like the one that we just uploaded, and metadata, like the attributes that we just looked at, can be combined in order to describe the contents of the data. And this is then this data set feature that we have here. This forms a data set. So let's create a new data set. Let's give it a title, new demo data set, and today's date, some code, test code, and also is also required. Put this together. So also required, and this is also required information. Now we can create it and enter this newly created empty data set. So now it's empty, there's not much in it, but let's have a look at the buttons that are currently there. For example, this home gives us a high-level overview. Next, the File Explorer gives us an overview over the data files, none there yet. Here then we can annotate the metadata, and here then we get a stream of activity that shows the provenance and the history of what happened to this data set, basically. And we can then release new versions, either minor or major releases of such a data set. So let's populate this data set. Let's go back to our project, to our data that we just uploaded. I selected here, and now it's here, and add this folder now to a data set. I select the data set. It's the new data set I just created, and I have just added this folder to the data set. So now we can see in the data set something changed. We have now in the Explorer data, the data that was previously uploaded, and this activity was also tracked, that just data was added. And now we can annotate the data with metadata, for example, with the already existing schemas of this project. So here is one of them defined. We can select all of the schemas that exist here in this project and can annotate this with the information that we want. So one, okay, and then submit it. Hello. There was some hiccup, but it worked. The new schema I just added is there. Likewise, we can also upload schemas, existing schemas, for example, in OpenMinds format. And also, if the data has a certain structure, it can be validated for its bits compliance. It doesn't have a certain structure. The button is currently not there, but this is another feature that can be done here. And then we have tracked the activity that happened here and can, at this point, maybe release the first version of this data set. We then have different versions of a data set, or at the moment we only have the first one. We can also directly create a new version. And we have two versions and can also download them again. Okay, I think this covered the main GUI functionality. Basically something very similar, or yeah, basically the same we can do with the command line tool also. Here's the documentation. So we have different types of commands like user commands, project commands, file commands. So user commands are for logging in and out. Project commands are for listing the existing projects, and with file commands, we can then upload or download files. So let me demonstrate this. So here we have a terminal. I already did something similar in the meeting before, but probably I need to log in, I'm not sure. It seems I'm still logged. Ah, no, okay. So I'm not logged in anymore. So let's log in with my username and password. Okay, and now we can list the projects. And now I can do the same as before. So let's create some new test data with some files. Okay, and now we can upload this again. I just look for the command. Here it is. And I'm uploading this folder now. So here's the
We have a
command.
question in the chat from Santiago Brandi. Is that happening locally on the VRE or remotely? Is the question.
So the terminal we are seeing now is on my local computer, basically. And from my local computer, I send it now onto the VRE. Thanks. Okay, and here is the command, VRE CLI, file, upload, and then I specify this folder I just created, and I specify the project and the path where I want to upload it, and I hit enter. So this goes via the HTTP protocol. So we have to divide this into chunks such that a web server is able to upload it, and it's done. And we can now look at the VRE GUI again and look whether the file arrived. And indeed, this test new file or folder with the files I just created is there. And likewise, with the sync command, let's also demonstrate this as the final demonstration. We can also download this again. Let's make a new subfolder. And I had the sync command already. Here it is. Yeah, I take the one I just uploaded, test, new. And the last dot at the end indicates that I wish to download it into this directory I'm currently in. Now wait, and it has been downloaded. We have a zip file and unzip it, and indeed it's the files I just uploaded. So now I'm at the end of this GUI and CLI demonstration. happy to take questions. And if there are none, I would then move over to the demonstration of Jupyter Lab. Provided by our colleague Mark Sachs. So let's share the video screen. I will also comment a bit. You should see the video. Let's start it. Okay, so here we are again logging in freshly into the VRE and directly starting Jupyter Lab. We can select different environments here. We select here this latest kernel that we have here and let Jupyter Lab start. Now Mark opens a new terminal here and again uses the VRE client to log into the core zone or the storage zone. And Mark first lists here his files that he has in his home folder. And here he has a notebook where he also installs software. So this is needed to bypass the proxy or to not go via the proxy. And here we can then download files or to be more precise, we installed a new pip package for Python, which allowed us to run our analysis workflow. And now we just step through this code here and get then a nice surface visualization here.
Okay, there's a new message in the chat. A question from Leah. When contributors upload files, will those files appear in the administrator's green room for additional revision before collaborators can download and analyze the data?
Exactly. So the specific role contributor can only upload files, but can not expose them to others, basically. And then the specific role administrator can then select is the uploaded data in accordance with what was agreed in this project. So here is to open a project, there's a data protection impact assessment, and the nature of this project is exactly clarified in this DPIA. And the administrator then has the responsibility of assuring that this is in compliance with the supplied documentation. So exactly, the contributor uploads the file and then the administrator selects which files should be copied to the core zone to expose it to the entire team. And at that moment, then the administrator gets a notification that this copy to core request was triggered and can then look through the files that are to be copied and can at this point still on a single file level basically agree or disagree whether a file should be really onboarded and exposed to others or not. And this operation is fully tracked.
Okay, thanks. There's another question. Can we access the data in the green room from Jupyter Hub by Arnold?
In your green room, yes. Yes.
Thanks.
So we have a new question. How much storage and RAM does one user in the VM have? and what are the constraints for running analysis on the HPC. Typically the VMs that are supplied by the Charité VMware team have between 8 and 32 cores and up to 128 gigabyte of RAM. But I think they are flexible with this. So if there's a certain need, then I think this can be accommodated. Then the next question was, what are the constraints for running analysis on the HPC? Are we talking about technical constraints here, or?
No, I was also wondering, because we currently always run into problems regarding large data file sizes and RAM. And I was wondering what the RAM restrictions would be for the HPC, but I understand that it's the same probably as the VRH one, or?
Patrick can much better answer this.
Yeah, it's not the VRH HPC, is Georgos already put on his camera. It's basically the Charité GB IT HPC, so he knows all the details.
Yeah, right. We have large machines also with memory on the HPC at the Charité, up to 1 terabyte memory, and up to 190 cores in a single machine. That should suffice for most use cases I know of, at least. And additionally, if you need GPUs to accelerate your jobs, this is also abundantly available.
Okay, but these the numbers you mentioned are shared across all users, right?
Yeah, okay. This the Charité HPC is a central.
Are there limits to the individual users' access to RAM?
We have some limits to ensure quality of service, that no one starves and no jobs starve in the queue. Of course, but the limits are very liberal. You get as a user 700 cores at once, or no specific memory limit, and up to 4 GPUs for the single case. If you have multi-GPU jobs or jobs that are more demanding, talk with us. We find an arrangement.
Good, perfect. Sounds great.
Great, many thanks. So if there are no further questions for me, I hand it over to Patrick. Thanks for the questions.
All right, thanks, Misha. Let me start sharing the screen as well. Yes, you see just the VRE window, right?
Yes.
Perfect. Okay, so Misha already introduced the portal, so we're just gonna skip through it to get to the VM part. I already selected a different project, not the indoor test project, but my specific project called Legion to TVB, because here I already have 2 VMs set up for my use case, so it's easier to highlight this a little bit. We're here in the canvas overview, as Misha showed. I'm in the green room. I have some data that I uploaded here called EPM. I already also copied this into the core, so it's already there as well. It's just some fake test data. Again, EPM is just pretending to be animals moving around in an elevated plus maze, just to have something nice to show afterwards. And the idea is I now want to process this data with my standard workflow that I have developed in my lab to plot nice images of these animals. So I have a Docker container that just runs a very small plotting script. So the Docker container is freely available on Docker Hub, just as, for example, most containerized processing pipelines, right? So that is easily available. I can use this locally, but I want to use this in the TVB, in the VRE, because we're talking about GDPR compliant environments that we want to use. So to do this, I go on the workbench tool that Misha mentioned but didn't show. That's the guacamole here, to see an overview of the virtual machines that I have available for me. In my case, I have a virtual machine for the core zone. I also have a virtual machine in the green room. I also have access to the TVB backend virtual machine where we have the virtual brain and brain simulation software already installed as a software inside the VRE that I use for my project as well. Now we're interested in the green room and in the core zone. We have two ways similar to the VRE command line interface tool of accessing our VMs. We can use a GUI version. We can also use a command line version. Because we had this question just a second ago about how can this data be checked before it moves to the green room? Can I look at this? I'm just quickly gonna actually start with the green room VM. I log in. And there we go. So now I have my remote desktop that I have available, my Ubuntu machine, and I can just use this in the same way that I would use my local computer. So we're thinking about making sure that I want the data, approve the data to be available to other users in the project. So move the data to the core zone. Can, for example, just install a Nifty viewer that I have in my case, because I do defacing as a pseudonymization step in the green room, and then I want to make sure that actually data is removed before the data moves into the core zone. So I can just, this is just the standard template that's always open at MRI-GL, but I can just open the Nifty image, look at it if there was a face. Now it's just the MNI template, and make sure that the data is actually fulfilling my requirements as the data controller. And if I'm happy with this, I can then go back to the portal and approve the copy to core request that the contributor, for example, has started. For now, we want to do some processing, as I mentioned before. So I'm just gonna leave this VM and go back to the core zone VM where I have the data copied. I'm going to use the GUI again because afterwards we want to look at a nice plot. So here I'm going to log in to do the same thing. The data, as you see here, I already downloaded it. We have the data, as we've seen in the portal, in the backend storage of our project. And I also move the data into the virtual machine where I can then do the processing using the command line interface tool, as Misha showed. And here I have the data downloaded, just a text file with the 2D coordinates of my animals, animal 2. And now I want to use the container that I have to process this data. So how I do this is similar as on my local machine, as I have a container-based workflow. Just opening a terminal, just go into the data folder here. I see EPM as where the data is downloaded, and I see a container. This is still empty right now. And to get my container, I'm just going to simply pull it. We have Singularity available because Ubuntu, we're obviously supporting open source. So we use Singularity to pull our Docker container. And to do this, I'll just say Singularity EPM is how I'm going to name the container. And I'm going to pull it for the Docker Hub, as I showed before, where I have my Docker container available. Sorry, that was the door. And I made a mistake. Oh yeah, I should probably tell Singularity what I want to do. I want to pull the image. And I had already cached it because I pulled it before, so that should be fast. I thought it was going to take a minute. Either way, we see now I have this container available. And now I want to use this container to process the data that we have in EPM, so the text file. What I'm going to do for this is, again, just going to say Singularity, run the container that we have here, and also bind the data folder. Is it called data as data? I think I called it. Container creation failed. I guess I have a typo somewhere. I have to provide the full path because Singularity. Oh, I'm already in the data container. Sorry. So it's going to be EPM. There we go. And now we ran our analysis. We see our progress bar is finished. And then if we look into our EPM folder, now we have the data as we had before, and we have our nice plot that we now can look at. the animals moving around in the elevated plasmase. This just as a straightforward, very simple example of how to run existing pipelines within the VRE. Just pull a container or also upload if you don't have the container publicly available. For example, during creation of the project before publication or something like this, you have a private container that you build. Just upload the image using the command line interface tool or the portal yourself. Have the container available. It's easy to run. On the other side, if we don't have, for example, containerized pipelines, but we want to use existing frameworks that we have in our lab, for example, SPM for analyzing our neuroimaging data, we can also just install any software that we require, right? Similar to the MRI code GL for looking at the neuroimaging data. I also installed MATLAB. So I can just, like if I would on my local machine, start MATLAB and am able to use whatever frameworks, whatever code I already have in my lab and now use it within the VRE. It's fairly straightforward. If you're a Charité user, it's also very easy because Charité provides campus licenses for MATLAB. And I know this is always an issue with MATLAB, but the campus license of Charité is already set up for use in the cloud environment. So this is actually, this was fairly straightforward to just download the latest version with my Charité account and install it in my machine. So that is straightforward to use. That being said, the same way is the approach to using Yurio's HPC environment. As Micha mentioned before, we have, or as we've seen also in the video from Mark with Jupyter Hub, because of the VPN connection, we now have proxies that we're using. So to make this a little bit faster now, I just actually connected to VRE virtual to another virtual VRE machine that I have here, the HF7 actually, and then let's play this too because I just ran this before. And if I want to submit a job to the HPC or move my data to the HPC, run the jobs there because I, for example, need a GPU from Georgios, I can just connect to the front end, to a login node, and I'm instantly connected because my user has access. It's added to the user groups of the VPN of the HPC, and I can have access to the standard full functionality of the HCP. I also have access to the VRE command line interface tool so that I can use it again, as Misha showed, to pull my data now from the backend storage of the VRE into the high performance computing environment and then run more demanding processing or analysis pipelines. And I think that pretty much covers the full functionality of just how to run workflows, how to run pipelines using virtual machines or the HPC. So happy to answer any questions if there are still. If everything was clear, I'm even happier.
I didn't understand whether the machines that you showed are something that you have customized for yourself and set up, or whether this is something that is available to everyone.
Those virtual machines are exactly like Misha mentioned before, the virtual machine that had been set up during project creation. So usually if you provide the DPIA, we're already talking about what kind of processing resources will be required, right? Because you're already given a description of your processing workflow, whether or not you will need HTTP access. So all of this is already then being set up. So during project creation, you also add a virtual machine to your project or to your user screen room that you can then use. So this was what has been done here as well. So those are the standard.
You mentioned as part of the DPIA.
I mean, as part of the project creation follows the DPIA, right? So first to get a project, we have the DPIA, and inside of the DPIA, we already described the processing workflow, the analysis workflow. So we already have an idea of the resources, or you as the user already have an idea of the resources. So when we then set up the project following the DPIA, the corresponding virtual machine, for example, with your resource requirements is then added to your project. And this is
okay, that's great. So what is the current process to onboard a project? or what is the status for us? Let's be precise. We have submitted the DPIA to the best of our knowledge. How can we get a virtual machine?
Maybe I can chime in here. So first of all, we need the statement of the data protection officer. Yeah, this is the first step. If that is available, then the project is created, and then everything follows as Patrick explained. There's a hand,
Also,
but maybe one quick question to you both, Patrick and Micha. How long is the video that Mark provided? Because I think you also want to play this, right? Just to have an estimate of the timeline.
that was the Jupyter notebook that Michael always showed. Right?
So Micha, do you know how long the video is? Did you plan to play the video that Mark recorded or not? You mentioned at the beginning.
Yeah, I played it already. I'm sorry, was this not visible?
Ah, okay. Maybe I was distracted by some other work. No, sorry. Okay, then there's nothing else planned. I just wanted to know whether we can use the time for the discussion now.
There are actually some questions in the chat. I think it's probably fastest if we just address them like this instead of typing it. Or do you want to go ahead?
Actually, there was a hand that now disappeared. I think it was from Sergio. Sorry, Sergio, please.
Yes, thanks. A quick question, Patrick, if I might. You mentioned you installed MATLAB and different type of software on the VM. How did you install it, if I might ask? And is there any, once the VM is up and running, is there any controlled inbound, outbound connectivity in the system or not?
For the example with MATLAB, I installed it as you would locally on any Ubuntu machine.
So when the VM is running, that you can access the data, is you have outbound connectivity or is it filtered somehow?
I mean, it is running through the Charité network security, right? Other than this, I just downloaded it using the browser. So
one of the, why I'm asking this, one of the, oh gosh, I just only now realized that my camera is not on, sorry. One of the things that we were scratching our head around our infrastructure is, if you want to allow people to install software, then you need to face the reality that 70% of this software has a high risk of containing malicious components. So how do you limit the possibility of data exfiltration from an unknown user, right? That's basically, so the MATLAB that you have installed is probably an example of a legitimate software stack, but I wonder if there has been a vetting process on the software that has been installed, that you did install, and in case once the VM is running, and then you actually run the software that you install, whether there is any mechanism to limit the outbound connectivity, so to control the data exfiltration part.
Maybe I can give first a high-level answer. Probably Micha can then detail this further. So the responsibility is with the user, and he signs that when he is using the platform, the user gets an isolated project, yeah, so that they can do whatever they want and run malicious software if they want, but they would harm only their own data inside their isolated space, and they are responsible for that.
Yeah, I have nothing, not a lot to add, basically. So exactly as you described, Petra, basically. So it's a virtual machine. The team is isolated in there. Yeah, the team has to act according to the DPIA. The uploads and downloads are tracked. And yeah, with this, compliance can be demonstrated, but ultimate security is not possible.
Maybe to also explain that this is, so we are not restricting users. Yeah, this is not the goal. What we are providing is the possibility to demonstrate GDPR compliance for a user, yeah, who needs to demonstrate it in order to process health data. And this can be demonstrated with our platform, yeah. But if, of course, the user then acts against the law, this is not our problem, because the user signs that he will process their data that they control according to law, yeah.
Well, in this case, it will not be the user acting against the law if he simply install a software from a public PIP repository, and the software contains malware that somehow exfiltrates data. I'm not entirely sure whether this could be considered as a malicious activity from a user. Are you anyhow tracking the outbound traffic somehow, so that you can demonstrate or can track in case of a data leakage from where the data leakage originated and when and by whom?
Yes, also all uploads and downloads are tracked. So you really have to go through this streamlined process, right? You upload it, then have to go this copy to core operation. It's tracked basically.
Is it so? If you can do Docker pull, you can do Docker login and Docker push. If I create inside the VM a Docker image that contains the confidential data and I push it to Docker Hub, will you be able to track this?
This is not tracked. So indeed, HTTP is open, but this was Patrick showed a special case here. So normally you would need to go the VRE client route basically, and really go the tracked route basically.
Santiago?
Yes, hi, thanks, Michael and Patrick, for the presentations. So I understand that each user can then create whatever processing workflow they desire for data they have. So is there kind of a built-in or predefined processing modules for example, MRI data?
Yes.
Yes, and just not to get into the details, but in at a high level, what is included in these processing workflows or modules?
Maybe I can also quickly respond to this. So in principle, you can deploy the workflows and pipelines that you wish to apply to your data, and several are available already, yeah, as containers. We are developing all our software as containers and make it available to the community. There's a defacing pipeline. Patrick, I think, can comment on this in more detail as one example. But in principle, you can deploy whatever pipeline is available for this purpose.
Okay, and just to have an idea of which type of processing is included at the moment.
Well, so each user has their custom-made processes, right? So it's not like a machinery that is built to serve the right functionality or processing for every user, but it's built such that the processes that are required for the data can be brought in and applied to the data. And as you might know from our collaborative work, we have all the workflows and pipelines that have been developed by Patrick, for example, for stroke data. Yes, this is probably of interest for you. And this is just one example of containerized workflows. Micha has developed some containerized workflows as well.
Yeah, exactly. So my question was that I understand it's fully customizable. I'm just curious about what things are already built for MRI processing. For example, for me, if I didn't know how to create a workflow, for example, and I just wanted to pick up things that are already built in, let's say, is there anything that I could use for MRI?
You can go to any Docker Hub. You can go to any Docker Hub and pull any container that you like and bring it in and process your data with it.
Very good. Thank you.
I think the time is almost over. Is there a final comment or question? We have 1 minute left.
Sorry, but to disrupt, but Petra, we wanted to also discuss the requirements for retune with the IT science IT. Did you want to have another meeting on that, or should we discuss this here now? I think your suggestion was to do it here.
Yeah, so what exactly are the questions that we would have to discuss?
So the question is, what do we as the INT project of Retune require from the science IT to present to the faculty? And we need one slide on that.
Okay, yeah. So actually, I thought more about if there are any technical matters that would need to be discussed. This would have been a good opportunity. I think we now have a good impression what is feasible with the VRE, and it's a lot already. And I think for the slide, we can have a separate meeting. I'm not sure what exactly to discuss now here, to be honest.
You suggested it, so I wanted to ask you what you would suggest to that, but that's fine. Whatever. We'll find a way.
If there are open questions, that need to be discussed, then happy to do this. But I'm not seeing a real question right now, so let's do it offline. Okay, then I think our time is over. We now deserve our weekend. I hope most of you now can go on the weekend. Thanks so much to Micha and Patrick for the wonderful presentation, and thanks everyone for joining the meeting. And maybe Jonathan, if you stay online, if you like, we can have a short chat, and also Julian. Yeah. Thanks everyone. Bye bye.